Hi, everybody. I'm Yanis. I'm working at the Ethereum Foundation. Super happy to be here. It's my sixth ECC, so always a pleasure to present here. I'm part of a team called the IPTF for Institutional Privacy Task Force. It's a team that was created last summer. It came from the observation that EF discussing more with institutions, we realized that the main blocker was actually privacy. And so we created this team to actually address this problem and listen to all the requirements that this institution have and build a lot of resources about how can you use Ethereum in a private way. So how do we do this? How do we answer this problem? We have many initiatives. The main one is a privacy map. So it's a fully open sourced work in the form of a GitHub repository where you can find a whole knowledge base about what are the different use cases these institutions have, what are the building blocks that you can use to address this. We try to form solutions in the form of approaches. And for institutions that would like to actually build something, we list vendors that actually provide the technology that we list in the map. We are also doing some proof of concepts. So here the goal is to not only speak about these building blocks, but have a hands-on approach of them. And so it's having more developing an engineering culture in the way we can answer to these institutions. And also we are doing some coordination with stakeholders in that are on the institutional market, and as well as doing workshops for these institutions where we try to dive a little bit more into privacy on Ethereum today. So why do we have this initiative? So as I introduced, we observe that the main blocker today is privacy, while it was regulation a few years ago. Now that the regulation in some jurisdiction is a little bit clearer, we are seeing a big push from these institutions to switch from private blockchain to public blockchain, and therefore the main issue that they have making the switch is privacy. There is also a lot of overlap with the 1 trillion security initiative at the EF, and also of course this notion of leverage that if we find institutions that resonate with Ethereum and we have success in onboarding them on Ethereum, it's a huge leverage for the whole space, but as well as the end user that would use these solutions. Basically Ethereum is public by default. So everything is public for an observer, and so we are trying to actually build mechanisms to prevent all this an observer to see all these public informations. So why Ethereum? Why these institutions now they want to make the switch and they have interest in Ethereum? I'm not going to explain here, but basically it's they want to access deep liquidity. They want censorship resistance because these institutions actually do care about censorship resistance because for them it's translated to no counterparty risk. They need a settlement shelling point, a neutral place where they can come and trade. And they also need a composability that Ethereum offers compared to the other models where you have full privacy, but you don't really have interoperability. It's a kind of a walled garden, and you also have vendors that provide this technology, and it's not very open about what you can do, and you can end up in vendor lock-in. So it's quite a challenge, but that's what we are trying to address. So how do we work? What's our day-to-day job? First is talk to institutions, try to find them, to meet them where they are. So participating in a lot of conferences, go there, try to have discussions with them, organizing workshop as well, and try to gather as much real requirements as possible. We don't want to speculate anything here. We just want to listen to the actual problems that they have and try to solve them. So as I said, all these discussions, they are open sourced. So we anonymize who we are speaking to, but then in our open source resources, you will find like a set of use cases that are actually like curated from these discussions, and we want this like to be like something that the whole ecosystem can use as, okay, so I'm thinking about my next roadmap and I want to tackle some institutional use cases, and then I can come here, like see the set of requirements and try to shape my solution going into that direction. Yeah, so we also list a lot of patterns. So the methodology we apply here is like try to think by the first principles, try to think like in terms of cryptographic patterns, like in terms of building blocks, and without not necessarily like an opinionated view on them. And then like from these building blocks, try to build a more opinionated view about like how to build a solution, which we name approaches. So basically it would be like, all right, there is this institution wanting to do like, that want to do like this private derivatives. How can we build a solution from these first principles? We also like want to do more on this side, like more like open specifications that anybody can like use and build from it, and also like playbooks in the form of workshops, guides for these institutions to actually use and understand more like the space. So just a sneak peek of the current state of the mapping. So we have like 52 pattern listed from shielding to TE to FHE. We have 20 use cases, and we also list 21 vendors. I think on that space, so that's probably like ECC is a good place to call all these vendors to come and like add their protocol if they want to address like some institutional privacy use cases. It's very open. You can open a PR, explain what your protocol is doing, what your tech is solving as institutional problems, and then we would be happy to have you added to the vendors, as well as if you have like a policy expertise. We do have like some jurisdictions artifacts trying to explain like how are the different like rules in each jurisdiction and how it's translates in terms of for builders, like what are the thing I need to implement to address these requirements. A recent change as well is like it's making sure that we give an overview of like crops alignment in terms of solutions. So of course, not all the solutions are like on the same line when it comes to like censorship resistant, openness, privacy and security. So we are trying, it's something that we just started, try to like give as well for institutions like some criteria that they can use to understand better like guarantees that a solution can offer. So this is like a breakdown from the privacy cluster of Ethereum, known also as PSE. So we can divide privacy at in different dimensions. So you have privacy of reads. I want to read the state of my state like privately. I want to be able to also like transact privately with privacy of rights, and I want to be able to like be sovereign, have sovereignty in terms of my own state, and be able to prove over my state, and therefore like have the capability to do that like on my own, like on my client. So this is the main tree track, and there is like also a side track which is like network. How do we achieve network privacy, and therefore like having the ability to transact fully privately. If you go to the maps or if you go to our work, like it's heavily like about privacy of rights, and there is like a clear explanation about this. Is that as I introduced, like we really like try to shape with from institutional requirements, and there is today a big push for tokenization, and therefore we try to address this problem. But I think that in the future we want to also have like a whole stack approach and try to map solutions that are not just privacy of rights, but how can you deploy from an institution? How can you deploy something that also protect like end user privacy in terms of reads, for example. So this is like some prototypes that we So we started to prototype solutions like in January. So that's like some things that we tried to hack in the last quarter. Again, I think the goal here for us is not to make big breakthrough, but it's like more educational. If there is an engineer from one of these big institutions that is like actually working on some project and wants to have like a sense of what's practical today to use on Ethereum, then he can come like consult like this proof of concept to try to like be to use as much pattern as possible without being like too much opinionated. So, like for example, we use TE to explain like where does it solve problems, but where it brings also like a lot of issues. Shielding, of course, like is one of the main primitives. So we tend to develop a lot of use cases around that because we think it is very practical. So we want to illustrate it the best as we can, and also we try to also address some use cases with Validiums and how you can have like your own private deployment. So the goal of this presentation, I'm going to zoom in a little bit on shielding because for a lot of these institutions, they're overwhelmed about like the whole privacy space, and sometimes they come to us and they say they want like something that is practical that they can deliver tomorrow, and they're completely lost. Like they're like, yeah, I've heard like that FHE is actually the best solution, or how can we leverage MPC, or what's the specific threat model of having a specific rollup architecture. So we tend to develop a lot on shielded tool because it's just that from our own observation, it seems that it's very practical and that actually like that in the short term like solve their problem pretty well. So I'm not going to enter too much into details, but it's just that just a rough specifications about like what a solution like this look like is just basically like the same old commitments and unifiers, and this whole construction like goes back to the zero cache paper, and we just want to do like more of this and more education toward this because we think that it's again it's practical, and it's like the space also proved that a lot of the privacy solution relies on it. So we just want to like make sure that we explain it from the first principles. Another good point about like why shielding is interesting as a primitive to develop and to double down on is that it gives you like some compliance features that are interesting. So you have like a separation of concern. You can have like keys that are only meant for spending and keys that are like meant for viewing. So like if I'm an institution, if I'm a bank, for example, I can just share my viewing keys to the regulator, and he can like audit my whole history of transactions. And also you can use it as a way to have a private KYC. So I can show that I can generate a membership proof that I'm part of like the people that have been KYC'd, and therefore like not giving my full identity there. So we've applied this like to for example a use case which is a private bond. Why we choose private bond is just because it's in this movement of like tokenize a lot of real world asset. Like bond is like the most simplistic form of asset because it's very simple. There is not a lot of operation, and just like you can, for example, apply shielding to a bond and just like change the data structure about your commitment and to suit like the requirements of a bond. Like in that case, it's just for example adding a maturity date and use the same shielding techniques on real world asset. And so also one good point about like about shielding applied to institution is that usually a problem with shielding is that you need to farm this anonymity set, otherwise like you don't have like plausible deniability. But working with these institutions that want to deploy at a large scale, it's actually make this mission easier because they can farm their own anonymity set pretty quickly. So basically you just you need like this component. You need a commitment scheme. You need as well as a nullifier scheme that they are all hash-based, Merkle membership proofs, and then like the dual key architecture to have like both like spending capabilities, but as well as vendor viewing capabilities. Yeah, I think we wanna show that shielding is could be seen as an abstraction, and just do more of it, like to, for example, help like if there is any initiative to like standardize the space, have like open specifications about like how to handle this type and how to build this type of protocols. That's something that comes often, like when discussing with vendors, is and vendors that are working with shielding is all right, like we should sit at a table and like agree on like what are the compliance rules, for example, when deploying like a shielded pools. There's also like a research to be done on this primitive. Of course, like as you have like to store like all these commitments and nullifiers, like you have a state bloat. So there exist solutions to that, but still it's not like there doesn't seem that there is a golden standard about how to solve it. Post-quantum is also like a topic. So while all the primitives of the abstract are post-quantum, because it's mostly like hashing, you still need to have like ZK proving capabilities, and therefore like there are some like benchmarking to do, like in terms of what's the best prover like for the next quantum era. Censorship resistance. Today, most of the shielded pools like rely on a relayer to keep the plausible deniability property, because you need to start on a fresh address, and therefore you need someone to pay the gas for you. There is a discussion about this new EIP 8141 with frame transactions plus fossil might be like the solution for that. But still, it seems that the frame EIP is not decided yet, and also like network privacy. Even if like your transaction is opaque in terms of data, still someone can like see that whole set of transactions coming from the same IP address, for example. So in terms of next steps, I think we want to double down on this framework with differentiating privacy for institution, but privacy from institution as well. So we want to make sure that the end user is not forgotten in the loop, and make sure that when we discuss with institution and doing education, we also like put awareness about like the end user. So for example, it could be like they want to deploy their private rollup, and we need to develop more technology to make sure that user can force exit, for example, things like that. So yeah, what's next? Like more work on the end user privacy. We also want like to, as I introduced, like have like a more whole stack approach. Like so, think about like how institution needs to deal with identity and credential, both internally but also like on a more like public standpoint. Governance and exit guarantees of this tech deployed by institutions, and as well as what can be done like at the network level in terms of privacy. And yeah, that's the end of my presentation. Again, like if you're working like toward like more like privacy for end user, we'd like to connect, but as well as if you're solving like institutional privacy problems, we'd love to have you like in the map. And we're also like publishing all our work on our website. So if you wanna check this out, please. Yeah, come and read our work.
Thank you for your presentation. We almost ran out of time, but maybe we can take one question. Does anybody have any questions? Yeah.
Thanks for the talk. At the beginning of your talk, you said your job is mainly about education for institutions. Do you also help institutions implement a solution, or do you leave that for the private sector, like with Aztec and zkSync deploying Previdium, or do you also help companies and institutions deploy private solutions?
Yeah, I think the goal here is if they are like really eager to put something into production or like do a more serious prototyping, then it's why we are listing vendors, and we are probably like just tell them, hey, we are listing vendors, like here are like people like you can follow up with and actually build with. We are not positioning ourselves like in the person that are going to help them deploy. We educate. We try to like our mission is at the end of the day they need to like make their trade-offs with like the full picture about privacy on Ethereum, and then they can like choose whatever vendor they want to like work with. Yeah. Thank you.